Welcome to the third episode in the episode series or the podcast series about coffee science. In this episode, we'll zoom in on the importance of simplicity in theories. And if you listen to this on your podcast platform, I'll just mention that it's also available on YouTube. And if you see this on YouTube, please go to our podcast and subscribe to our podcast so that you can take this learning to your commute or other more handy places for a long format like this. This episode takes as a point of departure Occam's razor. It's a principle that was developed by a medieval thinker, William of Occam, and this first principle I would like to introduce is what is often referred to as Occam's razor, which urges you to always look for the most simple explanation rather than the most complicated explanation, if nothing more is gained by the complication of the explanation. It sounds so simple and true, but this single principle is perhaps the most violated principle in the coffee community, as it seems that many people are making a great effort to overcomplicate things rather than simplifying things. So it is definitely worth mentioning explicitly and call out as a separate principle to apply from our historical heritage of scientific methodology. William of Occam is traditionally referred to with this concept, but actually already Aristotle came up with this principle. And to quote him from his posterior analytics works, he says, "We may assume the superiority of the demonstration which derives from fewer postulates or hypotheses." And William of Occam says, "It is futile to do with more things that which can be done with fewer." And examples where this principle is violated in the coffee roasting community could be these. Most of my students arrive to my classes with a strong focus on something called rate of rise that you with a roasting background should know about. If you don't, please pause and search a bit on the internet to find out what it is. But basically, it's the speed of the roast at different times during the roast. And they focus on the rate of rise rather than the overall time of different events of the roast. And my point is that rate of rise is not some hidden root cause for the roasting process that you need to look at independently to understand the roast, because it's just a simple derivation of a much simpler aspect, namely the shape of the bean curve that you already see even without calculating and plotting the rate of rise independently. It's already visible by just looking at the shape of the curve. You can use the rate of rise to predict how the roast will develop the next few minutes given the current speed, and you can use it to classify different roast profiles on how fast they roast, for example, after first crack, or other simple uses. So I'm not saying it's not useful, I'm just saying form follows function. You have to use it when it's relevant and something that you know how to use to come out with a prediction of anything specific. Shouldn't just be a default concept to use. And sometimes I hear claims such as, "I'm pushing the rate of rise mountain earlier in this roast," which is actually equivalent of saying, "I pushed the time to first crack earlier in this roast." And since referring to the simple time to first crack is much simpler than the rate of rise mountain, the time to first crack is preferred. The second point, the rate of rise can be reported in degrees per 15 seconds, degree per 30 seconds, or degrees per minute. Given that the roast logger software can optimize its own sampling rate independent on how the rate of rise is reported, it is by far preferred by Occam to be reported in degrees per minute, since this is the simplest expression and easier to use, for example, for future predictions of the roast. I've not seen any speedometers in cars using kilometers per 5 minutes or other strange time units, not directly and intuitively useful for the driver. The third point, development time ratio in roasting education is another overcomplicating concept which we will deal with later, because it also violates a lot of other aspects of a good theory. And my central problem with this theory is that I don't know what it predicts at all. But most of the students I get on my online courses from around the world would tell me the development time ratio before the time to first crack and just development time in good old seconds. And most roast logger software would show you development time ratio rather than development time, and you have to actively change it in the settings of much of this software where the development time ratio is default if you want to have your development time displayed in seconds rather than in percentages. No wonder newcomers to coffee roasting thinks development time ratio is more important than development time, if most systems would tell you development time ratio by default. Occam would prefer to just report the roast in minutes for each phase, and only when specifically needed derived values can be calculated if they are needed specifically, and the purpose for doing it is explicit as well. For development time ratio, I don't know when it would be relevant, where I see some situation where rate of rise could be useful. Point number 4. In a YouTube video with the title A Rant, Espresso Ratios and Recipes. And it's a video by James Hoffman, and the link is in the show notes. He is ranting about brew ratio that I've also thought about, and it was really relieving to see him annoyed with exactly this. I think this is another good example of an overcomplication of the concepts used in brewing theory. People will often tell you the ratio as if that is the central aspect of the recipe, where I would like to just know how much coffee do you use and how much water goes through in order for me to directly make the coffee. The ratio I'm old enough to calculate myself if I need it for a specific purpose. Just as rate of rise tells you something about the speed of the roast at different parts of the roast, the ratio tells you something about how concentrated a brew you make. This is a time and place. There is a time and place for rate of rise calculations and also brew ratios, but it should only be used if there is an explicit aspect of the roast and brew that you need to evaluate, and never a substitution or default reference concept. Occam would prefer keeping things in minutes, degrees, grams of coffee, and milliliters of water in most cases, and only when specifically needed do these derived values for the purpose at hand, which is probably needed much less than done by habit in the coffee community. There might be an element of ego sticking out for people using these concepts a lot. Doing these calculations gives you an aura as a scientist, but people with a background in science would see through this example and will see it as an example of sophism in Plato's terms, as you take what sounds scientific just in order to persuade your audience to perceive you as a scientist, where you're doing the opposite of a real scientist and thereby misleading your audience and put them in a basement of the cave with artificial light, rather than out of the cave where the true light of knowledge is shining on the ideas behind the world itself, to stay in Plato's allegory. Point number 5. Defaulting to calculating and using ratios and speeds in all situations rather than just using them in a very specific and situation, and only situations where they could be useful, has another built-in problem. you actually lose information in both type of calculations. If you provide me with a recipe for a brew or show me a roast curve, I could always calculate the ratio, rate of rise, or development time ratio myself. But if you give me the ratio, rate of rise, or development time ratio, I can't go back to the recipe of the brew or the roast curve because I have lost information during the calculation of these derivatives. You have the same ratio in a 1 liter brew. You can have the same ratio in a 1 liter brew and a 200 milliliter brew, and you can have different rate of rise on roast going through the same process if the probes are differently placed or if you have different roasters. So it's not a good ground for comparison. Likewise, a roast with total roast time of 10 minutes and first crack after 8 minutes give you a development time ratio of 20, which is also the case for a roast with 20-minute total roast time and first crack at 16 minutes. What does the theory kind of predict about the similarities of these two completely different roasts? The fact that you lose information when calculating the speed of a process can be illustrated with mathematics by looking at the technicalities of finding the speed of a power function by applying the power rule, which is beyond the scope to explain in this oral medium of a podcast, but I've found good explanations on Wikipedia and Khan Academy, so please go to the show notes of this podcast if you want to see how information is actually lost in the process of deriving the speed of a power function.